Okay, so I've decided to make a little video about barbecue science. It's a great way to look at conduction, convection and radiation and cook a chicken at the same time. So the chicken has been brined, which means soaked in brine water first, which is salt water. Then I have covered it in a bit of bacon, a little bit of bacon here stabbed into its back, some little bacon feet, and then I've covered it in some brine mix for the South African flavour. Okay, so I'm going to go a little bit further with my cooking today. I'm not going to do a radiant cook, right? And a radiant cook, what that is if we look at the barbecue here, we have a vaporizer on top of what are essentially gas burners. And when you turn on both of the gas, you heat up this piece of metal, and then that piece of metal radiates heat out, electromagnetic waves, infrared radiation, and that can be used to cook meat or whatever food you're cooking. But what we're going to try and do is a convection cook instead. So that will be where I just put one burner on, which will be on the right hand side, and that one burner is going to actually also heat up. Inside here I've got some wood chips. Inside here I've also got some wood chips, right, moistened wood chips, and some holes here and here and on the back as well. This is just to stop them from actually igniting and just produce smoke, because I'm looking for that smoky flavour for my chicken. So I can put this back on. I've got a little bit of water in a half of a can here. This is just to keep things nice and moist. And I can place my chicken got a tray underneath it so I can capture any juices that come off it. Just tuck the wings in so they don't burn. Okay, so let's explain what's happening with convection. This side of the barbecue will be on, okay, which means hot gases are going to be produced here. Those hot gases, when gases get hot, the particles in the gas move around faster and they end up actually occupying more space. So if you've got, well, think about something which you know is dense, something like gold. If you've got a fistful of gold, it weighs a hell of a lot. If you've got a fistful of polystyrene, it doesn't weigh that much. A fistful of gold sinks in water. A fistful of polystyrene floats in water. In fact, the rule is, if the object is less dense than the fluid it's in, it will float. So the hot gases here, which become less dense as they are moving around faster, expand. They're now less dense because they've expanded, and the fluid rises. Colder fluid will come in to fill its space, get heated up, continue. The hot gases that have gone up may cool down a little bit, get a little bit denser and sink back down again. So we should get a continuous cycle inside the barbecue oven, and that's going to allow us to convection cook the chicken. Okay, so we also have conduction, right? So conduction happens in solids. It can actually happen in fluids kind of as well, but we'll just concentrate on solids for now. So if we have this piece of metal here, if I put a flame to this end or heated this end, heat would move through this and eventually I'd burn my fingers. So let's think about what's actually happening. You're heating this end up, the particles vibrate faster and faster. They're actually in a solid, so they're vibrating about fixed positions, and they bump into the particles next to them, which makes them vibrate, which make the particles next to them vibrate, and that's one way in which the heat moves through a solid. Now, because this is also a metal, it also has free electrons, and the free electrons can also whiz around and transfer some of that, what we'll call it thermal energy, but in reality it's kind of a combination of kinetic energy and potential energy stored in the sort of strain in the bonds of the metal lattice in this case. So yeah, the thermal energy moves through the material. So that's conduction. Radiation, on the other hand, is completely different to the other two. Radiation is the formation of an electromagnetic wave. Radiation heating or transfer of energy, thermal energy through radiation is very much like the way we see as well. So it's a type of electromagnetic wave, much like microwaves, visible light, gamma rays, all the rest of the electromagnetic spectrum. It travels at the speed of light, which is 3 times 10 to the 8 meters per second, and hot objects, all objects are emitting infrared radiation. In fact, anything with temperature anyway. If it's at 0 Kelvin, that's the only time it's going to stop radiating infrared radiation. All right, Adrian, should we check it? Should we check it? You see all the smoke rising? See it rising?
Is it from the back?
It's coming out the back as well. So what's that?
Smoke.
Smoke rising. Smoke rises because it's hot.
Chicken in the barbecue.
You see the chicken starting to cook already?
Isn't there?
Come up here. Cooking away. Is it cooking? You see the smoke rising and with the lid not closed.
Lid?
That's just water to keep it moist. Pebble my chicken. Okay, so it looks like, well, the 2 hours are up. I think the chicken should be cooked. So, hello Mr. Chicken. As you can see, I've stuck on a few more things. I'm going to use my meat thermometer, stick it in the thickest part of the thigh, but without touching the bone, and check the temperature. So what we get in here, as long as it's above 75 degrees Celsius, then I think the food is cooked. Seems to be bouncing around a bit, but oh, don't tell me you died. And the battery's gone. Not to worry. These do work by conduction, so it's still linking into the same stuff. Chicken looks ready to go. Should we have a look at the stock? This is what's going to be turned into the gravy. There's onions, there's chicken fat, there's also some fat from the bacon and other bits and pieces, and there's garlic, and I think that's going to make a really nice gravy. All done.